Okay, so hi everybody. Sorry I'm out today. Had to go to a meeting. I'm just going to do some quick little review problems for your one pager. Um, so for your one pager, some things to remember. Um, if you are asked about factoring, this will be for a quadratic. And if you had something like 2x squared um, plus 8x plus 6. This is just an expression. Your strategies for factoring, you want to make sure you make yourself a box. Sorry, and that should have been 2x squared. You would put 2x squared here in the first box and 6 in the back, and then you're going to start breaking up your quadratic. 2x times x, and I'm going to break this into a 2 and a 3, and I have to decide if I want the 2 to multiply the 3 or the 2. And I think if I do 2x times 3, I'll get 6x. And then x times 2, I'll get 2x. And then I think that makes 8x, like I'm looking for in the middle. And so my factored form is x plus 3 times 2x plus 2. And there's just a kind of simple example for factoring. If we'll do a simple example for graphing. I think on your study guide, there's one that has some negatives in here. We'll do one that's just a little bit easier that doesn't have quite as many negatives. So we'll still have some, but not quite as many. And we'll have this do x squared. And then just 1 second. Okay, so we have x squared minus 10x plus 21. Our first step is we're going to factor this. And factoring, I would get x squared, and this is 21. I want this to be x and x. And then think of things that multiply to positive 21. 7 and 3 multiply to 21. If I make them both negative, then I'll have negative 7x, negative 3x, and I get this factored. So my factored form are x minus 3 and x minus 7. So now I'm going to start my graphing. When I'm looking for my graphing, I focus on starting with my zeros. So my zeros for my function for x. So what are the x values that make that 0? 3 is the first one that makes that 0. And then 7 is the second one that makes that 0, because 3 minus 3 is 0, 7 minus 7. And then I'm going to go ahead and graph my my x-intercepts. There's 3, 3, 4, 5, 6, 7, and here's 7. If I wanted to count to the middle, I would go to the middle. I could also always add my 2 intercepts and divide by 2. So 3 plus 7 is 10, divided by 2 is 5. That's the same result as kind of counting to that middle. Now to find my vertex, I'm going to plug in 5, and I would do y equals 5 minus 3, which is 2, and then 5 minus 7, which is negative 2. And I will get down here that my vertex is happening at negative 4. So my vertex is 5, negative 4. And that seems right because I have a positive leading coefficient. Should go here. If I was to go up, this is going to connect to the y-intercept at 21, and that will keep going. Okay. So for solving for, I should always check to see if you have something that looks like this one up here, factoring is the way to go. For solving, you definitely want to make a note that if you have an equation that looks like this, 20, you should be, this is like a perfect square, and you should be square rooting both sides. So I'd square root both sides, and I'd end up with x plus 5 equals the square root of 20. When I do this, I get a plus or minus. And then here, what I'm going to have is, I need my calculator. So I just went and grabbed a calculator. And I would be grabbing the square root of 20, which is the second, and then the square root of 20. I'd end up with 4.47. So I'm going to have two answers, the positive version, which here I'd have 4.47. And here I would x plus 5 equals negative 4.47. Then I would subtract 5. And then I would subtract 5. 5 minus 4.47 is 0.53. And here, when I subtract 5, I would get x equals negative 9.47. And that's kind of that solving. If I have something that looks like this, 3x squared minus 4x plus 5 equals 0. I always want to have 0. If it's not 0, I need to make it 0. And then I don't think I'm going to be able to factor 3 and 5. They're odd. They're never going to make an even number. So I'm not going to make 4 in the middle in any way. So I am going to have negative b plus or minus square root b squared minus 4 times a times c all over 2a. And in here, a would be 3. B would be negative 4. I'm really going to have to watch that because it's going to have a couple of places where it gets to be, and I think I just wrote a quadratic that's going to come out as an imperfect. But for time's sake, to keep this kind of a little bit shorter, I would then be plugging those all in and solving. This particular one is going to come out with no real solutions, I can already tell. And the reason it'll come out with no real solutions is because when I do 4 times a times c, that's going to be a bigger number than b squared. But maybe I'll stop it to the point when I can see that. So b here is negative 4, so I will have negative 4, which is going to make that into a positive, plus or minus square root. I'm going to do negative 4 squared. That's going to become a positive because negative 4 times negative 4. And then 4 times 3 times 5. This is all going to be over 2a, which is 2 times 3. So when I start simplifying this, that's going to simplify to a 4. This right here, this inside is going to be 16, and then 4 times 3 times 5, that's 12 times 5 is 60. And here's where I'm going to get a negative number, and this is going to be no real solution. Because here 4 plus or minus, and 60 minus 16 is 44. Of the square root of negative 44. So I could write this with an imaginary number, or I could just leave it like this. There's no real solutions. All right, I'm going to flip this over, getting close to being done. If I have trigonometric ratios, we remember these with SOHCAHTOA, and I'm going to try to do 3 example problems very quickly. So it's the sine of some angle, that's a degrees, equals the opposite over the hypotenuse. And if I was ever if I ever had an angle and if I had the sides but not the angle, I could do the inverse of the opposite over hypotenuse. And this is going to give me some angle, right? If I was looking for an angle. Here I plug in an angle. If I do the inverse, I'm going to get out an angle measure. And here the cosine of some angle, that's the adjacent side over the hypotenuse. And the tangent of some angle is the opposite over the adjacent. Opposite over adjacent. And just to review right here, okay, so sorry, going back to this. So then if I have my triangle, if I was, say, looking at angle A, my opposite would be all the way across. The hypotenuse is always the long side across, that's across from the 90-degree angle, and then the adjacent is the leg that's touching A that's not the hypotenuse. So a very quick example of how you would find a missing side. A missing side, if I have a triangle that looks like this, and I have that this side is 15, I'm looking for X, and this is 22 degrees. I first identify what pieces that I have here. The X is the opposite, and this 15 is my hypotenuse. Opposite and hypotenuse, that would give me so. I know the sine of 22 degrees is going to be equal to x over 15. In this direction, I'm really going to be multiplying by the 15. So I'm going to be, to find x, because I can multiply both sides by 15 to really get that, undo that operation, I'm going to have x equals 15 times the sine of 22, which I used in my calculator for. So on my calculator, I do need to make sure it's in the right mode. Right here, it needs to be in degree mode. So I hit the mode button and then I check the degree. Once I'm here to get out of there, I can hit second and then quit. And then for my calculator, I do 15 times the sine of 22. And I would get 5.62. And that's my answer. If I was going to do an inverse, say I had a triangle that looked like this, and I was looking for the measure of angle A, and I knew that this one was 13 and this one was 22. This is gonna, if I identify, this is the opposite side, this is the adjacent. So I'm gonna use the tangent, but since I have the sides, I'm gonna use the inverse. And the tangent is opposite over adjacent, so that's 13 over 22. And then when I do this in the calculator, it's gonna give me the angle. So second tangent, and then 13 divided by 22. And I get 30.58. And this is degrees. Okay, hope this helps. Happy studying.